Oh, yeah, I need the clicker. Cyril,
Oh, I can.
talk.
All right, so we're going to talk about 5 years in Loki turns 3.0.
Okay, all right.
Here we go.
Thanks, bud. You can leave now. You're done. No. Okay, yeah. So I mentioned earlier, Cyril and I have been working together for a long time. Both responsible for putting a lot of bugs in each other's code. So hopefully some of y'all can kind of share that experience. Yeah. So Loki 3.0, 5 years in. Touched on a couple of these things earlier. I will pace, so beware. So let's take a look at what this brings. But before we do, I want to take a step back and kind of look at some of the initial things that we wanted to do when we set out to build the project, how that's changed over time, and how it still influences what we do today. Basically, what changed and how it stayed the same? Okay. Anyways, these were from the slide earlier when I originally put together this deck. I didn't realize we were going to be doing the keynote and then this like almost immediately after. So you've just seen this. And I have some extensive notes I'm reading down here. It says growth and exciting. Thank you. So how do we get here? It's really helpful for a project to have a clear purpose. So ours was distributed grep, for developers and operators. Okay, helpful. We really try to focus on ease of use for targeted search initially. And if you kind of go look at the somewhere out there is still the old Loki design doc. And it has like a lot of things that we do now, and it was like, we're explicitly not going to do these things, but things do change. So it's built on a couple of these principles here. Standard cloud infrastructure, right? More and more important in today's world, right? So it's microservices, orchestrated in Kubernetes, written in Go. But we also have other forms to run this. You can kind of start small in what we call single binary, where everything is co-located in the same process. That's helpful for development, but you can also kind of extend that and run small projects. And then there's an intermediate mode we call SSD, simple scalable deployment, which is, if you're trying on microservice, you want some distribution and isolation between different components. And then finally, the kind of full-fledged thing, that's kind of what we run in cloud and a lot of people run for larger scale things. Basically, we can go from your laptop, or your Raspberry Pi to thousands of cores in the cloud. And there's some configuration difficulties, but all in all, not too bad. We also separate storage and compute, and this is really helpful when you want to scale them independently. And my favorite one here, I'm going to be talking about this a lot today, bytes, not records. Loki is schemaless. This is really important and really fundamental to the nature of the project. We do not care what your logs look like. They can come from Nginx pods that you do not control, really. They can come from things that you do control. They can ingest JSON and log format and all manner of other stuff. I've seen people put GIFs in Loki. Do not do that, please, but I have seen it. So this is what it looks like. Basically, there's a couple different pieces here. Nanosecond precision timestamps, these are indexed. Prometheus-style label pairs, we use Prometheus as a library internally in Loki, basically built on top of that project. So the same, basically, key value pairs you use for Prometheus labels, we also use within Loki, and it helps you correlate these two things, logs and metrics. And then finally, all of the log content. I actually don't like this slide because the log content is tiny here, right on the right, but in reality, it's many, many times everything else. So I need to change that, but anyways, no schemas. You can ingest stuff from anywhere, any team, any language, no problem. This does pose some challenges, and we'll talk about that. So what does this minimal indexing look like in practice? Now, for us, this is from one of we call them cells, but Loki database clusters that we run internally. Ingesting was 43 terabytes a day of raw logs, and it comes up to just shy of 200 megabytes of index for that. So in real terms, that's somewhere over 200,000 times smaller for the index. So this is not really a traditional thing. It's a table of contents, not an appendix. It tells you where to look. And then Loki basically scans the appropriate data, and we could parallelize this in many, many different ways across the commodity hardware that we talked about earlier. So, this next slide is fun. I went and looked back through like a bunch of our old releases, put them up, mapped them. This took me an enormous amount of time to make, actually, so you better appreciate it. And it shows kind of the velocity of the change, sure, like as we add different features, but there's some other stuff underneath, but this is not exhaustive, but illustrative. I tried to generate this image, and the idea is that you kind of have to balance scale with features. You always want to build new features for users, for yourself, and hopefully those are the same user base. And then on the other side, sometimes you have to kind of eat your scale vegetables beforehand to get there because, it's an ever-increasing need in today's world. So this is the previous slide, but again, kind of overlaid with all of the kind of maximum, the fastest queries that we would see running at kind of different phases of Loki's evolution. And this is kind of a really fun one. It's non-linear, the growth here. One of my kind of favorite anecdotes is back in like the really, really early days, we ran about 10 gigabytes a second maximum query throughputs. And by today's standards, I mean, tiny, right? Yeah.
Yeah.
But it actually works. It worked for us as we were building out Grafana Cloud in the early days. And I still hold it, it's still highly usable there. But anyways, so it kind of shows how we've tried to balance these two things, adding new features and support for new use cases while also being able to support, the underlying scale requirements of it. So Loki 3.0, there's a kind of a change in how we think about some of these problems. Because up till now, we've really improved query performance, mostly through additional horsepower. New ways to parallelize and kind of distribute work across, thousands of cores. But the future is probably not more of that, it's probably less. It's probably not scanning more faster, it's not scanning stuff we don't need to. So being more efficient with our time and our energy and our resources, while also staying true to a lot of our principles here. And so, story time. This is something I found out last year. So Loki stores its data in what we call chunks. They're compressed logs that we dump in object storage somewhere. 75% of the time that we spent downloading and querying chunks was completely useless for our purposes. Right? Now they were requested, like the queries wanted to iterate that data, but it turns out there was never going to be what they were looking for inside. So this is what I mean, right? We probably want to work a little bit more efficiently. Okay, so how do we do that? Because this becomes a lot when it starts being measured in petabytes of data and thousands of CPU cores and things like that. Yeah, so I've got an anti-schema rant here, both because Loki doesn't really like schemas, but also because I used to run into this problem all the time where I would build out using things that kind of required really, really rigid structure. And I ended up spending more time in my org, like working on pipelining backwards compatible changes through everything, than I was on actually getting value out of the things I was ingesting. So we need to do this, but we need to maintain simplicity, rather. And indexing here is like the super obvious choice, right, for a lot of reasons. But kind of wanted to challenge ourselves here and do this in a way that didn't kind of fall prey to some of those things I just mentioned. So it kind of comes down to a couple points here. We want to stay true to the schemaless, unstructured search that Loki has always done. And then the other one, which is the kicker, is unstructured data kind of lets you, in ingesting that is a really, really nice benefit, primarily for operators, and to some extent, developers and whatnot. But we want to extend those same easy-use benefits to people querying Loki. We don't want them to write huge query plans and really, really painful, long, exhaustive things to be able to get data out and to get data out effectively. So we want to write something that's transparent, meaning that you can get faster queries automatically that are more efficient just because it can kind of detect what you're looking for. So this is actual photo of me when I was a little younger. And again, end of last year, we were kind of going back and forth on a lot of these kind of more traditional ideas. And I was sitting here kind of asking myself, like, is this possible? Can we do this with these kind of constraints that we've given ourselves? And so brief aside, it's really important to surround yourself with people who will like push you to not do the thing that's most obvious or easiest at hand, but to keep uncovering the next idea until you get to something that you're really, really excited about. And so Cyril's one of these people for me, for sure. Ed, Brian, some people on the databases side of Grafana Labs really kept trying to get me to find the next thing. So one day I had this idea. Okay, what if we took an impossibly large amount of data and put it into an unreasonably small space? Right? Basically make a sketch of what your data actually looks like, but don't store it in and of itself. Because a sketch doesn't have to be precise when you're interested where the data isn't. You just care where the lines have been colored in and where they haven't. And in our case, if you remember back to the 75% of data being bad, not necessary for our use cases, that's just as, or arguably more important than the 25% of data that we actually want. And so in a way, eliminating data that we don't want is the same thing as finding data that we do. So I started putting together an idea, and it kind of felt like a mirage. Again, I tried to generate this picture too. I think there's like a monster there, but the idea is there's a mirage and you're kind of, you can't tell if it's real. So we went through a couple iterations of things that seemed like there's no way this is going to work. It's going to be impossible for X, Y, Z reason. These are some of them. Started building some of these experiments, knocking down bowling pins one at a time, so to speak. And finally got to the point where, hey, maybe we should just build it. So looking at time, I'm going to go a little quickly through this section. We're going to be at the booth later at the AMA. So if you want to come kind of talk about how this works internally, please. Love to nerd out about that. So anyways, Bloom filters in 30 seconds, as I say up here. Basically, this is, I think about this as like a kind of negative search. We invert the problem. All it does is it takes keys, it maps data into buckets, and it just knows if the bucket is empty or full. Now, the cool part about this is that you can then compress that down, well, reduce the size of it, because something being empty or full is basically just a bit. It's a 0 or a 1. So you can get a lot of data into a very small space. And the next bit here, n-grams. This has long history in full text processing, things like that. They're just character sequences, fancy word for character sequences. These are the trigrams. N can be any number. These are the trigrams of length 3 for the first 1, 2, 3, 4, 5, 6, 7 letters of the alphabet. So what if we take these two things and combine them? We ingest all of your data. We extract n-grams from them. We put them into Blooms. And we cross our fingers, right? Like, does it work? Now, it turns out that this gives us the ability to kind of index unstructured data, but to do it in a space-efficient way, kind of combining these two properties to automatically index everything. Now, brief example. This is like a HTTP path. So I'm looking for /users. If I want to query on this, I basically have to run all of the n-grams, test them all. And if a Bloom returns, says, oh, hey, I match all of these things, then I know I need to check that data. Otherwise, I can discard it. So the next kind of big question, which I spent a lot of time trying to really, really understand, was, I guess, two things, right? Well, one, why is this so big? It has to be too much data. I remember talking to Tom here somewhere, and that was like the first thing that he said to me. He was like, there's no way, no way. And I was like, I know, but anyways. So it turns out that logs are about 90% template and 10% variable, on average, give or take. But that's the idea. So here's a real example of what a log glide kind of looks like by, partitioned by how often that is repeated over successive lines, right? So we realize that a lot of that is just there all the time. this template. Some of it changes a little bit, and then a few things have really, really high entropy. So basically, the noise here outweighs the signal. Now, there's a cool property about blooms, and it's that duplicates are completely free. So you can kind of see where I'm going, right? Yes, this should create a lot of data, but because there's so much noise relative to the signal, so much duplication of data, of templates, actually ends up working out. So we've run this in a bunch of different places, but basically we see the size of bloom filters at around 2 to 3% of the underlying log size. So what does this actually look like? Here's kind of an example of a logQL query, and fizz1234, like some UID basically, transaction ID, if you will. Right, so kind of support use case. We're seeing these types of things a lot more in Loki. Not just the developers and the operators kind of scanning the logs when they understand their systems and understand that, I care about this application from this cluster at this point in time. But hey, I'm looking for support logs. I'm looking over all of my prod infrastructure for this over a week-long period because I don't know where it comes from. I don't know what my infrastructure looks like. So, turns out this is unique, and it has a lot of n-grams inside of it, right? So we can test that. Now, one of the really cool things here, so this is an actual example of what this looks like for us. And we're filtering out 90-something% of all of the data, and this happens automatically. We are implicitly looking at what users are querying for. In our examples, kind of filter expressions, we call them in Loki. And we are extracting that, we are running them against the blooms for all of our queries, and then we are just discarding a bunch of data that we know will never match. So all in all, the kind of root of that idea is very, very simple. This is where we're at right now. So I said experimental support, and that's very true. So it definitely works. There's going to be a 3.1 at some point, probably next couple months. And by that point, we'll probably be a little bit further along and really, really operationalizing it and making it easier to run for everyone. And there's also a kind of a number of things that I want to clean up to make this, to tighten it up. Oh, I ran through these pretty quick. Yeah, you're going to have some time for the demo. So this is Cyril. Cyril's going to come talk about Loki and OTel. Thanks for your time, everyone.
All right, thank you. So OpenTelemetry, I think everyone loves OpenTelemetry. I mean, vendor, not all, standardization. The problem is Loki doesn't really like it. It has been built for unstructured data, and ultimately OpenTelemetry spec is actually structure. So makes it hard for Loki, not just the backend, but also the UI. Like the experience is not that great. So in terms of querying, obviously, we are trying to make OpenTelemetry in 3.0 much better. So you're not going to need the new JSON parser in your queries. We also improved the UI, so it's going to be a bit better. So you're not going to have like a big blob of JSON, which OpenTelemetry end up being. And operationally, you're also not going to need the gateway anymore. So we used to have like another component to ingest and transform OpenTelemetry format into what Loki could understand. So it will be natively, from now, Loki will be natively supporting OpenTelemetry. We also used that opportunity of a big release to clean up. So we did a lot of cleanup, mainly configuration. So we've been running Loki for more than 5 years, and it was a good time to maybe update the default with all the experience that we have. So and also make some breaking changes, like remove some storage that we were supporting before, some legacy features that we don't think should stay there, and also improve the metrics, make sure that all the metrics that are in Loki are valuable. So we did a lot of cleanup. Right, Elm. So we are going a bit bigger on Elm. We used to actually not be that big on Elm because we are a JSONet shop at Grafana. But the community wants Elm, definitively. So we are going a bit bigger, and we have like 3 different install depending on what you wanna use Loki for. So single binary for the Elm lab kind of installation, simple scalable if you just don't want to run the big thing from the start, but still scales with like a read and write path that is different. And then the distributed version, which is the one we actually use at scale at Grafana Labs. And that one scales to the terabytes per days. So we also, you're going to see the docs in 3.0. Big shout out to the docs team, but also to the whole team working and improving the installation, starting ingesting, D0 experience, making it better for everyone to get started in Loki. It could be rough at some times. Now we are just making it clear all the things that you need to get started and how Loki can be installed. All right, last section. So I touched on this already during the keynote, but I want to tell this story because I've seen this story many times. I don't want to learn LogQL, and I've been biased on that because Owen and I have been using LogQL for a long time, and we find it super powerful. So I was like, why what's the deal? And I realized, okay, SREs, platform engineers, they usually learn PromQL, and then they transfer that into LogQL. And then, they build dashboards like this one with mixing logs or building metrics out of the logs, and it works well for them. But then they go to the app developer, which normally should be focusing on their business, right? Not learning another language. And it's too complicated for them. And they don't want to learn a new language or not necessarily, from the start, get value without having to learn a new language straight away. So that's actually a quite complicated query. I bet not everyone in the room understands what it does. And so I think this has been a big problem for Loki. And that's what we tried to solve. So first iteration, I think Torkel touched on this during the keynote. We were like, okay, let's just make a query builder. But then the problem is you still need to understand the data model, you still need to understand the query language because ultimately you're still building a query. Instead, we decided to build a new app which we called Explore Logs. It doesn't really require you to know about LogQL, but more to explore the logs and use the app and just clicking. I think everyone loves clicking, especially Matt and Jonathan. All right, we have time. I'm going to show you a couple of features that I haven't shown in the keynote. So let's do that. Cool.
You want it full screen?
We can, I didn't do it full screen. Yeah.
I can do it this way.
Yeah.
Yeah, good.
Cool. All right, let's do it. Perfect. All right, so I'm going to start with, so this is, as opposed to earlier today, this is actually a real workload. So this is not like a generator of data. I wanted to show you how it looks like in our dev instances. So the first thing that I haven't shown is, you can search log, obviously. You have a text box here, and you can start typing words, and you don't necessarily need to know about the language. So this is something that I didn't show earlier. And it reacts automatically as you start typing. So again, no query language, just trying to explore your logs and finds what you're looking for. I want to touch on the labels. So let's see if the Wi-Fi can do it. So this one has much more labels than before. So maybe I'm going to need to refresh the page, not sure. All right, I'll give it a refresh. All right, here we go. I want to show you something is at Grafana Labs, and probably in any company, it's quite hard to keep all labels under control. We have a lot of them. But we have a new API in Loki 3.0 that is actually trying to tailor and only show you labels that will be interesting for you to break down and use to filter down. So, things like ID usually will go away automatically or will not be shown by default. Things that have like too high cardinality, past the 500 element, it's almost going to be impossible to use that to try to figure out how to filter with it. And so we try to use the right label, like level, containers, pods, to try to find inside your label. And Loki does that automatically. I want to show you the detected field, how it works on a real workload. So this is actually, the Grafana agent running in our dev cluster. And it's kind of very interesting to be able to see, for the caller, which is a very popular log format, fields, which gives you the log site, where that log comes from in your code. And you can have a sense of, quickly how much each Go file here is actually logging. So this one is actually, very iterating often. You have also, for instance, the components. All of those are extracted directly from the log line, and you can, use those to filter. So I can add one. Now I'm filtering on cluster. I want to show you, so I'm going to remove this filter here. Let's go. All right, so again, that's the pattern. So I wanted to show you the pattern, how it looks like on a real workload. And you can see the trend again of that one here. So the way the pattern works is that it's going to actually add wildcard in elements that are viable, and then everything that is the same between all the log lines is going to group them up as a time series and show you the pattern. That is a kind of powerful way to see a huge amount of logs, but restrained to just a couple of different patterns. Again, this is a new API that we added in Loki 3.0. And we're going to keep working and making it better. It's not there yet for some of the other format, like JSON is a bit harder, especially if the key moves around. Some people really like to have JSON and the order of the key going differently. You shouldn't do that. Right, so you can use those filter to filter down, and only look at these patterns of log and get detail of that specific pattern. Right. So I can, look at all the different receive file watcher event, but all the different names here. So very powerful to not, explore your log without having to write a single query. The pattern is actually a new syntax that we added in LoQL and in Loki 3.0. So what you can do also is open in Explore. It's actually going to show you the query that it's using. So you can learn about LoQL by using the app, and you can share it with your colleague. And you can also use that to just add it to a dashboard. You can go and then add to a dashboard without having to type anything. I'm a beginner in Loki, and I can quickly go and use it. So we really want to make it easier for the app developer to get started on using Loki without having to learn the language. So this is just the beginning of this app. We really worked only 4 weeks on that. We're just going to invest much more. We have a lot of ideas, a lot of new features that we want to build. Also want to make it a bit better and do some tweaks and adjustments. But really, really proud where we landed. So again, big thank you to the team who worked on this, and also everyone who worked on Loki 3.0. I think we can switch back to the slide. So I think we have 2 minutes. Should we have 2 minutes left, so maybe we can take some question. Right, let me see. Right, so I already showed that slide. So if you don't want to install it, you can just go on play.grafana.org and then just give it a try there. If you want to show it to your colleagues, you don't even need to install it. Obviously, this is new, so do provide feedback in the channel community, Loki channel in the community Slack, or directly create an issue on the repo. Thank you.
Nice job, man.